Otherwise, take it away.
Hey, thanks, John. So, like John said, I'm Melissa, and this talk's going to be about Swift 2.0, or Swift the sequel, as I like to call it. And so, I know we've already seen a few presentations and some different types of code, but who in here is mostly working with Swift? Is anyone mostly working in Swift 2.0? Sweet, awesome. So feel free to chime in. So I think something with Swift 2.0, why it's really great, we have to look back to what made Swift, the original, so great. And so sure we all remember back in 2014 when Apple announced they had made this new programming language, and it was going to be faster and more safe, more modern, and because they took Objective-C and what they said they took out the C part. They made a programming language that was for Apple products, for Cocoa frameworks, and it made it so that it could be fast and it could have all those modern things like closures and generics and other multiple return types, and those things we like to use now. So, and that brings us to Swift 2.0. After they announced Swift, it quickly grew popular and everyone really liked it, but also with so many people using it and making the switch, that did generate a lot of feedback. And so Apple aimed to improve Swift, and their goals of Swift 2.0 was really to improve the fundamentals, the safety, and the readability, or the beauty, as they called it so many times during their dub this year. And so I think if you can see like the goals with Swift 2.0 and with Swift 1, they really kind of align with each other. So I don't think Apple took a different direction when they made Swift 2.0. I think they really aimed to make Swift even Swiftier. So if you're still working on Swift 1 and you haven't really made the jump yet, don't be like too afraid, because I feel like there isn't a lot of changes, only really improvements to the language. And if you're still on Objective-C and haven't really made the jump, I hope this even gets you more excited. Groupie looking at you to make the jump to Swift. So let's start with some of the fundamentals and some things I'm going to touch on with their compiler, their new comments and enums. So with the compiler, a lot of complaints Apple got was with error messages that would throw up in Xcode, and you read them and it would almost look like machine level code where you're like, I don't know what this is saying, I don't know what's wrong with this line of code. And so there's clearer messages that really tell you what's wrong and why. Like you can actually read them, so that's good. And there are new warnings that help you optimize code and like make you kind of force you to use like the best code possible. And some of these warnings are for variables that have never changed. They tell you, use a let. That's a better way of using that. And then when a variable was never used, it lets you know about that. And also different functions, like you have this sort function or the map function. The sort function in this case. Those functions return a new array of values. And so what this is saying is like, hey, you don't use that return value. You can use an in-place sort instead, and it's going to be a little more optimal because those functional functions are a little bit more timely and costly. So if you don't need to use those return values, there's really no reason to. So rich comments, I like to think that the day I decided that I wanted to become a developer was the same day I realized I hated writing documentation. But I think Apple is trying to alleviate some of that pain with making documentation a little bit better. And a lot of people use like second-hand apps, like other apps besides Xcode, to make their documentation, like Mal and stuff using Markdown. But now they've incorporated Markdown language in Xcode itself, and you can use like playgrounds to make really thorough and really documented comments and documentation of your code. And if you're like making APIs or libraries and clients are using them, this is really helpful because they'll get the whole scope of everything when they use your code. And that's like a quick look that's going to pop up from your rich comments made in Playground. So the next thing are enums, and they enhance three different things. Enums, enum printable, associated values, and recursive types. And the printable is pretty self-explanatory. Basically, instead of not getting anything very useful when you print out an enum and having to kind of go deeper and print out like its name or its raw value as a string, you just print it out like this, and you can get the actual type of that enum. And so associated values, how enums used to be with types where you have an enum of type string, and all of your enum types would be strings, or they would all be ints. And so associated values, if you're familiar with other programming languages, you might know this as like discriminated unions and variants. But with Swift, there's another type of enums, and you can actually have associated values where your different cases of your enums have different value types. So like with barcodes, nowadays we don't just have numbers on barcodes, we have like QR scannable codes. And the QR code, when you scan it, you get a string. But it's still a barcode, so you still want to treat it like a barcode, like its other counterpart, which is UPCA, which is just your basic barcode you're going to find on a product in the store. And even though they have different values, they're still enums of like the same type, same barcode. So going off of associated value enums, there's also recursive types. And that means that you can have the enum type, like the value of the enum like case, can actually be itself. So a good example of this is when you have like arithmetic expressions, like with parentheses. And you're going to have multiple, like you're going to have addition, multiplication in one parentheses, which might also conjoin with addition from another parenthesis. So you have a lot of recursion going on with that kind of thing. So if you see this kind of enum, my little arithmetic, you can see this being utilized where the addition and multiplication types actually use arithmetic as their value types. So this is helpful when, like I said, when you're doing things with like math or very logical heavy things, so you don't have to specify really like a lot of different types of enums. And these all have the indirect keyword in front of them, and that directs the compiler to make an indirect layer between the enums and the type, and that's what makes this possible. And if all your cases in the enum are going to be recursive, then you can just put indirect the keyword in front of the declaration of the enum. You don't have to declare it every single time. So one of my favorite things with Swift 2.0 is the pattern matching. And so you have things like the guard and availability checking. So those of us who did Swift 1.0, we got very comfortable with if-lets, and we got very used to them. And the point of if-lets was to check optionals, which was another thing inducted with the birth of Swift, to see if the optional actually had anything there, to make sure it wasn't empty so that we knew we could use it. But we realized if-lets quickly became kind of messy. And if you look, this is 6 different nested if statements with 3 different nested if-lets, and it's kind of crazy. This is a sample from my actual code that looks kind of atrocious, but you know, you gotta do what you gotta do. And so you ended up getting stuff that looked like that. And it's kind of hard to follow, hard to read, but what it does, it always accounts for like the positive case. So if an if-let, if your optional has something in it, your if-let is going to be positive and it's going to be executed, whatever you have in that execution block. So with Swift 2.0, they introduced a guard statement, which is almost the opposite of that, where it accounts for the negative case or the false case. It's going to guard and say, if instead of if-let, your optional, if it does actually have a value, it's going to look at if it's empty. And so it's going to focus on the negative case. And so you might think, well, that's kind of weird. It almost seems not intuitive. But when you look at it, when you look at the flow of your data, your code, it actually is a little bit more readable because you can see where you have your guard-let. I've called it a guard else because it helps to kind of reiterate that you are checking the negative case, like every guard has an else statement with it. And even though it's called a guard statement, not a guard else, you always account for that negative case, which is why I call it guard else, just because it helps you remember that you're checking the negative. So in here, you kind of see that if this is almost the same amount of lines you would have in an if-let. It's still like the 2 checks right there. And you have the executable part after the else, and then you go on and do everything else in your function. But there is one difference where your eye might catch it if you're very used to if-lets, is when we declare this middle name right here for the person.middle name for the type on that object, this isn't just in the scope of the guardlet. It's in the scope of the entire function. So down here, when I go to print it out, once I've made sure that it's not empty, I can just print out middle name. I don't have to use person.middle name, which really, that aspect of guard is really fundamental to guard itself, because the point of guard is that it makes it so the rest of your code doesn't have to be nested in an if-let. So all your important code isn't nested somewhere deep in like 3 levels of if-lets. It's all on the top level. And so you can use those unwrapped optionals, if you will, everywhere else in the scope. So when we saw the if-let versus the guard, like the one guard and the one if-let are kind of comparable to each other, but like we said, where we get into trouble with if-lets is when you have so many of them. So how do you handle multiple ones with the guard statement? Well, let's say if my original struct of my person, if all of those were optional types. So this guard else is going to look something like this. And at first you might think, well, that's basically the same amount of code, but when you go to actually read it, it's a lot better for early exits. Or what that means is when one of your conditions fails. And so you don't have to have all these conditions and then go down to all the closing brackets to see what happens when those fail. It's right there after each one. So you know, okay, if there is no last name, that's what's going to happen. Or if there is no first name, that's going to happen right after that guard statement. And so it's the same way where if you look down here, those are all in scope, where I can say first name, I don't have to make a reference back to the person object itself. I can just say first name, last name, middle name, which again, I think is really great because it's not huddled in so many levels deep, and you're not having to wrestle with so many different variables. It's just a lot more readable. And also, if you notice the return statement in each guard statement. So every guard has to have a return call, or it has to kind of let go of the control. So in a function, that's going to look like a return. You're going to return out of the function. And so Swift 1.2 introduced optional bindings where you could say if-let and then have like 3 or 4 different variables you were checking separated by a comma. And you can do the exact same thing with guard. So we didn't lose that capabilities at all. And that's what it looks like. It's basically the same as the if-let with the commas. It's denoted this way. And like I said, with the return statement, you have to release control. So if you're in a for or a while loop, you could use a break statement, which would kick you out of the entire loop, or you could use a continue statement, which would just kick you out of that one iteration and then keep going to the next iteration. So availability checking. So when we go to handle APIs and functionality in newer operating systems while supporting older operating systems with our app, it can be a little tricky. And before in the past, some solutions were to do kind of an if statement, like an if check with like response to selector, to see if your object responds to the selector in its library or in its methods. And so that can be really problematic because it's really easy for like errors. You could spell the selector wrong and you can never find it. You can forget a colon. It's really fallible. So what Swift 2.0 introduced is actually an availability keyword, which with the help of the compiler, the new Swift 2.0 compiler, it actually can notice, it'll tell you when you're using functionality that is not in your lowest level of your target deployment operating system. So it'll catch it and be like, hey, this method isn't in this operating system version. So what you have now is this if pound available. And this is one of the easier things and probably one of my favorite ones just because it just makes so much sense. It's like, well, yeah, why didn't we have this, before? And so what you do is if the certain operating system is available that you want to test, then, or that you want to, that has a new feature you're trying to implement, like this one right here is for the Force Touch or 3D Touch. Then you check for that operating system, and then you say then operate that. And if it doesn't have that operating system, then it just skips it, like any if statement would. And that star next to it just means that operating system or any newer operating system that's come out. So yeah, that's probably my favorite, even though it is one of the more simple ones. So protocol extensions is another new thing that Swift 2.0 lets us do, and it seems like a very simple idea. So previously in Swift, we could extend classes, and that looked something like this. You were using arrays in your app, and you wanted all your arrays to be able to do something. And so you made an extension, like a method that did this, which this one just counts it counts up the number of trues in the array. So with this is using closure, but with protocol extensions, you might want to not just extend array, but you want to extend collection types. Because if you look, like this isn't specific to arrays, like the actual code isn't, so why not use it on other collection types? So a protocol extension is going to look like this, which is almost exactly the same. You just have to extend the protocol name instead of the class name. And so why is this such a big deal if it's like so simple? It seems pretty much like second nature. We know how to extend classes. Why are protocol extensions that much more important? Well, Apple also introduced protocol-oriented programming to Swift, and now Swift is being actually touted as a protocol-oriented language. And so Apple did a whole presentation at this year's DubDub that I would recommend everyone watching because they seem really excited. They really seem like this is a new paradigm, the new direction they want to go with. And the premise of it basically is, I think, that they find classes just too heavy. Like, you can do a lot of really great things with classes that, like inheritance and namespaces and everything that goes along with encapsulation. But they said, why can't we do all that stuff with types? We can do that stuff with structs and enums. We don't need classes. We don't need all that extra baggage. And they said that these were the main three problems with classes. You have automatic sharing where their subclasses have the same references to the same data of their parent classes, which often causes a lot of bugs. And fixing those bugs often leads to more bugs. And so those are really hard to keep track of. And then inheritance can be intrusive, where a class can only have one parent class. And so sometimes those superclasses just get huge with all the things you have to include in those classes. And also you have lost type relations, where sometimes your methods in your superclasses have types that don't follow in the subclasses, and when you call those methods, it gets kind of blurry as to what type is being used. And so just to touch on this a little bit, because protocol-oriented programming is like a huge topic that could deserve its own presentation, I'll just briefly talk about it a little bit. But with protocols, you can still do the same thing, like with access control, abstraction, and namespaces, with all the heaviness. And a big thing that they talked about was like self relations instead of the like lost type relations. That was kind of the fix for that with superclasses, where you have types that you can't keep track of in your subclasses. Instead, you pass in self as the parameter, and that kind of generic type really means that you can only call those methods on the type of object that this superclass is. So that's a little bit about that. But like I said, protocol-oriented programming is a really huge topic, and it's too much for another presentation. On to error handling. So if you take away one thing from this presentation, take away error handling. If you haven't been paying attention this whole time, now's your chance, because this is probably the most important thing. And the reason why is because everything in Swift 2.0 that used an NS error anywhere in its method has been updated already. So you have no choice. You have to use this. It's not an option. So you will have to learn error handling. And so we remember what error handling looked like in Swift 1. You had an error pointer that you passed into a method, and then the method, if there was an error, it wrote to it. And then after you had the method, you had to check to see what happened with that error. Did anything get written to it? Was the method a success? Is the error nil? And you kind of had to handle it yourself. And then you had to kick it back up to whatever method called this, and then you have all these chained methods that are passing each other the same NS error, and it got really crazy. And this is a little bit going off of the whole safety thing of Swift, where they wanted to make it more safe. This is not very safe because you could easily forget to check your error, forget to check like what it is, or even if it isn't nil. You could even not pass in an error. You could say, oh, I'll just leave this nil for now, come back to it, forget, and it's nil. You don't even pass an error, so you don't check. So that is really unsafe. So Swift 2.0 handling looks a little bit like this. This is a really simplified version, but you get the gist. You see the do, the try, and the catch. And you try something, and you catch it to see if there's an error. So you might notice like some of this new verbiage going on. And if you've worked with like exception handling in other languages, you're probably very used to try catches, because a lot of other languages, when they handle exceptions, they do try catches. So these are the keywords you're going to use and you're going to see in error handling. The throw, throws, do, try, catch. And also a note about do, they actually changed their do while loops to repeat loops so that they could free up the do keyword for this purpose. So that's another small change they made. So Swift 2.0 handling, back to this. So the do indicates what the whole block of code that you're going to be executing that might throw an error. And the try keyword is in front of each statement, each specific statement or function that is throwable, that is going to throw an error. So then the catch, which you might have figured, is what executes when and if that error is caught. So in this example, the function that is throwable is thinking, this thinking function. So if we take a look at what that looks like, you see something like this. So that's where you have that throws keyword. So the function thinking, in the signature, you have the word throws to let you know while you're reading it, like, okay, this might produce an error. So then you can put in your logic of what you're checking for that is a problem, what might throw an error. And so this is just a simple if-else check. And so we see that you throw this error, and this is a custom error that's made right here. So in Swift 1.0, you could make your own custom errors, but it looked a little bit like this. You have like a lot of boilerplate logic going on, and granted this is like 10 errors, so like it looks a little bit worse, but you can see you have a lot of repeated code. It's very repetitive. But with Swift 2.0, this is what your custom errors look like. Basically, you just have to make an enum that conforms to the error type protocol and make your cases and name them, and it's a lot easier, as you can see. So if we put all these pieces together, the function and the error types, we get something that looks like this. Okay, let's make sure it reaches all the way up. But yeah, so you have your enums, and then you have your function that you define that it throws, and where it throws, and what it throws. And then when you go to actually implement that, you can actually implement different catches for different errors. So it looks like how these guys are right there, where you just say catch, and then you have the enum type right there, and it checks it in line just like that. And this catch at the bottom is like kind of like a base case, where if it's like an unknown error, something you didn't check for, it'll default to this one, and that's going to be like an unrecognized error that gets thrown. And also, you don't have to like have specific return statements in the catch statements, because those automatically return. Once it catches an error, it's going to return. And so that leads us to, well, what if there's other stuff in this function that needs to execute even if there's an error? Even if there's an error call, we still need to finish what the function does. And that leads us to the defer keyword, which you might equate to the finally keyword that used to have. And so defer denotes a block of code that's going to execute whether there was or was not an error thrown at all. So, and you can even have multiple defers and multiple deferred like blocks in your code, and they'll all execute on the return of your function, which is really helpful. And also with error handling, there's a try that's really excited. It ends with an exclamation point. And so it basically operates the same way as if you were to force unwrap an optional, in the sense that if you do it wrong, your app is going to crash. And so it asserts that whatever you're trying won't throw an error. And so that sounds kind of scary. It's like, well, why would you ever use that? But if you're reaching for something that's like very low level in the app, like its main window, or it's like directory or user default, and it can't find it, then that is a problem. Maybe the app should crash. And so that's, I guess, the purpose of the try exclamation point. And another thing I wanted to talk about with Swift 2.0 was something that got a lot of excitement right after DubDub, and everyone was kind of talking about it. But now that it's been a few months, it's like kind of died off, and I don't even know if it's still happening. But at DubDub 2015 back in June, they announced that Swift 2.0 and everything was going to be open source. And it was a big deal, because it's like Apple's open sourcing their programming language. Like, that's crazy. And so, like I said, everyone was talking about it, but now it's been a few months. They said at DubDub that later this year it's going to be open source. But here we are in October. Haven't heard anything. We had iOS 9 drop, and the new iPhones dropped, and still nothing about the open source. So we'll have to see about that. And as far as what it means, like for us as developers, I'm not sure if it'll have a direct impact. But I think with Apple, when they announced Swift, they said, like, this is the new language. Like, we want this to be used everywhere. And I think this kind of is going to help them achieve their goals for it to be multi-platform, multi-device language that can be used on a lot of things, not just Apple. And also, when you have people are interested in programming, and specifically for Apple, they want to make an Apple, they want to make an iOS app. Sometimes, especially like students and kids, they might not have a Mac that they can code on, or they might not be able to afford it. And instead of them having to be reduced to Android programming, open source would be able to, people could build those tools where they could develop on a Mac. They could develop on whatever computer they have, where they could make their own compilers that work with Swift. So I think it's only a good thing, really. I'm all for open source. So I'm excited, and I hope Apple still takes this direction with it. So yeah. Any questions?
I was just making a comment about the open source.
Yeah.
So I lead Ray on Blitz tutorial and Swift tutorials, and I know that one of the things that we're really trying to do with the tutorials is try to make it platform agnostic.
Okay.
Like, we try not to use any code frameworks and anything to try to make it where it will work well on Mac or on Linux or whatever. We want to make sure that all the tutorials are open to anybody who is programming Swift on any platform. So we are still thinking of it, just aren't necessarily talking about it, because I don't know what's going to happen yet.
Ooh, that's good to know. Anything else? Any other comments or discussion points? I know we have lunch coming up, so yeah.
I've still got time because it hasn't gotten here yet.
Oh, never mind.
Can you go back to the recursive email?
Yeah.
You kind of broke my brain on that. What's the use case for that? How would the one that you showed behave?
Yeah. So the use case with it is really kind of specific, where you would basically make, so the one I showed you is specifically for a function that was made to work with this. And it was basically made to pass in numbers and to evaluate them with as like an expression, but only using the enums. So basically, what happened was they made a switch statement that had like if they checked all the cases. Basically, it was if the number was, it's going to return the value of the n, and if it was addition, it was going to call the number case on those and add them together. And if it was the case multiplication, it was going to call the number case of the case of the arithmetic case and multiply those. And so what you get is once they made this kind of large switch statement is they implemented like kind of their own functions. They didn't really pass in they didn't pass in an already made expression, but it was more like given these numbers, and then they wrote it out themselves where you could see like I'm talking about Apple by the way when I say that where you can just call like at the enum like addition, and the switch statement operates because it was like evaluate. So you have a function called evaluate. Within that function, you have a switch statement. And so when they went to the actual operating code and they call it evaluate, well, all they had to do was say like evaluate addition 7, evaluate addition 3, and so it kind of just made it so that they didn't have to say like 7 plus 3 times 5. They could do it in this really probably unnecessary way, but it's really cool. And then when you get into more complex like expressions, and also expressions that aren't just handed to you, like exactly what it's going to be. Expressions that you say, like we're probably going to have to see: is it addition? Is it multiplication? Is it division? Are there parentheses? That's where it's going to be useful, not in very easy stuff like that. So I would say for basic things you're going to do with enums, I don't know how useful it's going to be, but when you do get into more like protocol-based programming and you're using structs and enums instead of classes, I think it's going to be a lot more useful. Does that answer your question?
Yeah, I think that is helpful. Not to experiment with that.
Yeah, it definitely takes a lot of like tinkering to like really see how the things are touching each other.
I was going to say another use case for this would be JSON structures where you have a tree where you have a bunch of different possible nodes that they can be nested in each other.
Yeah, that's definitely a good point. And when they demoed this, actually, they did show like a tree with nodes and how that would be beneficial.
That's what I was going to say too. That I saw like Swift 1, I guess it was 1.2 because I didn't see that this was out. It was a lot of these kind of boxed in kind of hack arounds to try to build a tree out of an enum like that. Is this another branch or is this the final thing? To where being able to just kind of keep drilling to get to the final object. I didn't know that would work with JSON.
Yeah, so that's another thing about too. Like typically with recursion or recursive functions, you have like a base case, which is at the point where you would be at like the final. Is that what the case number?
Yes, exactly. That's going to be your base case where the addition and the multiplication are going to at some point make a reference back to just handing you the number. And so when the point of making them all indirect, I'm kind of curious about like how that's going to work when you don't have a base case. So that still kind of is a little bit baffling to me. So I'll have to also like tinker with that.
You'd have to have a base case otherwise eventually.
Right, because a base case is one of the like properties of recursion that you have a base case. So I'm not sure how all of them could be indirect unless they were connected to another enum that had a base case.
Good way for a lot of recursions. Back to error handling.
Yeah.
We'll talk about try question mark.
Okay.
We'll talk about excited try.
I did.
Unsure.
Unsure try. Try.
I love you.
So yeah, so try question mark is similar to try exclamation point with the checking to see if you can throw it or not. I don't know if you wanted to elaborate on.
It's just like it showed in one of the last betas, and it's the safer version of the excited try.
Oh, that's good. Safer is better.
You can try it without all the catching, but it will return the nail if it throws in there. You will get your error. You'll just get nothing.
Okay.
But
It won't crash your app.
it will close your entire resistance.
You're still handling failure, even though you're not handling the error itself.
Yeah, and that's good because, like I said, it's not going to handle it. If it does fail, your app is going to. So that's good. What beta is that in? Do you know?
Probably 6, but it's out now. So.
And with this, you were showing, originally one of the Coco APIs takes the NSR pointer.
Mm-hmm.
Yeah. Is there any facility in this that automatically throws exceptions for methods that are within that older style? Like, if I wanted to do this right to URL, but I want to avoid this having to do this in Swift 2, is there something that is sort of would let me do right, do a try right to URL and have, and if an NSR happens, have it automatically throw an exception?
Yeah, so these methods, any method, like these frameworks that use NS error, they've already been like converted.
But open source code, third-party code would have to do its own.
Oh, I see what you're
But
saying.
there's
So
nothing automatic that does something based on the signature of the method.
I see what you're saying.
Yeah.
I don't know. I guess that's a good point. I'm not sure how, like, if you are pulling in another framework, how that would really operate. I don't know if you have to put try catches like on top of it, like kind of like a wrapper almost. I'm not sure how that would really work. I don't know if anyone else has a better idea of how.
Well, I pulled up a project last night that was written several months ago, and it expected asked me to convert the project.
Yep.
So this was like the new syntax. And then it brought up the changes. One of the changes was I do try, obviously convert the left to do try catch. But under the catch, you can, set a variable and cast it as like an error. So like catch bar error equals an error, and then the error is still defined like that bar at the top. So
Okay.
it's still using as errors, and you can cast the error itself. The exception, as an error. There's a throw exception, it still throws error. Okay, then you get the error. You can, that's just what I saw. But I'm going to go out and delete that because I don't, we don't need to use it in this error. That, I think that it just couldn't automatically convert it. That was like the second thing to do.
It did a pretty nasty job for one side, but had to go on the podcast.
Yeah.
Is it try to get it to where it wasn't crashing, but it leave like overly complicated kind of confused.
Right.
Catch. Crazy.
Yeah, I wanted to ask about conversion. That's not really officially part of Swift, but they did have conversion from earlier Swift to Swift 2. Have you worked with that at all?
Yeah, I found that it's better than like some of their older conversions where like when you get like the diff of it, like it'll show you kind of, I think, a little bit better like how each one is being converted, like each category thing be converted in the diff. Like you still get like the diff you might get if you do commit or whenever you upgrade. It shows you that, and it shows you each thing that's being upgraded. I mean, I think there's still room for improvement, like kind of like what we talked about with the errors, but I think it does a pretty solid job. So whenever you open up an older version, like a Swift 1.0 version code in Xcode 7 or higher, it's going to prompt you immediately, like, hey, Swift 2 is available if you want to upgrade. And if you click yes, it's going to take you through that automated process of like looking at the diffs and then upgrading.
What was your
I found that it did pretty good for the most part, but just especially with the error handling, it would get to where like it was kind of working, but like a lot of it's report was checking for that error. And every single thing that you were trying, it's doing the try, and then catch error as NS error, do this thing with it that it really didn't need to do anymore, and then like a kind of generic catch underneath it, since it doesn't necessarily have to be an NS error. There's more unnecessary than broken, I think, for a lot of it. But I spent a lot of time playing that kind of those to make sure they were doing what I expected them to.
We converted that 10,000 line split 1.2 project to 3.0, and it took about 6 hours. Not for the process to run, but like for us to clean up after.
That's been my experience too. That there's a lot.
I see. Yeah, I haven't converted anything that's like 10,000 lines, so wouldn't have had that like experience.
6 hours felt pretty good for that kind of project.
Yeah, compared to the past conversions in Objective-C, it's another line.
Anything else? Thanks, guys.